Welcome everyone, and thank you for joining us for the Managed Pressure Drilling New Drilling Convention, the season finale in our 4-part Weatherford series. My name is Ian Cook, Vice President of Secure Drilling Services, which includes the product service offering of Managed Pressure Drilling. I spent about 15 years with Weatherford and over 20 years in the oil field in various positions, both in international and domestic roles, from field supervision to management, with the majority of my time spent in the MPD space. So a brief overview of the presentation today will include discussion on the MPD outlook now and into the future, inclusive of cost, risks, and overall deepwater trends, how we address the challenges of deepwater, and how we see the technology evolution in the coming years. So just a few general comments before we get started today. They include, at the end of the discussion presentation, we'll reserve 15 minutes for Q&A. Please feel free to submit your questions through the webinar and throughout the webinar using the Q&A icon at the bottom of your screen. For our on-demand listeners, please direct questions to mpdanswers@weatherford.com. So to commence the early discussions, we'll look at the past to provide some color on both future technology developments as well as how MPD has expanded over the last decade or so. So really, industry acceptance of the technology really started in 2003 and moved from how can I drill this well in the early days, 2007, how can I improve the economics of this well, and then moving past post-Macondo is really how can I improve the operational integrity and safety of the entire drilling process. So the process has really moved from drillability to efficiencies and onwards to safety, and I'll refer back to this slide a few times during discussion, but what we're trying to paint here is the evolution from the start, approximately 2003, and we'll try and project out to 2020. So as we know, deepwater expansion with the new high-build specification rigs, they really came onto the market pre-2013 and throughout that year, with some deliveries in 2014. And with this growth came the need for a new game-changing technology such as MPD. In 2014, the MPD market space hit critical mass, and that threshold with the technology gaining considerable customer acceptance across most large basins globally. So from 2018, we expect this growth to continue, or at least outpace growth rates of other similar drilling technologies, and grow to the coveted mainstream and become the new drilling convention for deepwater drillers. So to highlight some of this move to critical mass, Weatherford has experience across all applications from land, shelf, and deep water, across all geographic areas where drilling challenges are prevalent. Leveraging our skill sets from 2003 and building extensive infrastructure has enabled this growth to occur. From 236 land wells, 103 jackups, and 51 floaters in our portfolio on varying well types and drilling domains speaks to the future of the technology and mainstream adoption. So let's spend some time on today and some of the macro trends that are shaping the current environment that we all work within. Today's reality is clear. Well construction costs and risks must simultaneously come down. Whether it's non-productive time, wellbore stability, and/or unmet well objectives must all be addressed now and into the future. So in basic terms, and to highlight some of this macro environment that we're working within, you often read in the public domain that easy reserves are gone and how non-productive time significantly impacts well costs and are a paramount concern on how we as an industry must continually strive to better protect the health, safety, and environment as a whole. All speak to the need for better technology across the find and develop process of our customers. So here are just a few examples of how commodity pricing impacts break-even costs for large fields, such as Brazil's pre-salt and other challenging fields globally. Today's pricing reality means that costs need to come down significantly if deepwater expansion is to resume. If you take Brazil Libra, for example, on your far right, $60 break-even Brent costs, 2014 run rate pricing or costs for that particular well need to come down 30% for this to be an economical play if we believe that $60 Brent is here to stay. And to highlight other concerns, if you look at the last couple decades, or almost there, a decade and a half, production has not kept up with spend. And here's an example. In year 2000, annual spend was approximately $18 billion on the E&P side. Today's spend is over 110. This is a $90 billion difference. And if you look at the production curves, you can see minimal increases. And the actual increase is about 6%, which more or less equates to about 1% production increase if you compound it year on year versus a 14% compounded annual growth rate on the E&P spend. Obviously, these two need to come together, and by driving down well costs, these curves should get closer together. So we spent a little time on how we lower well costs and highlight three key areas of opportunity to meet today's new pricing reality. Reducing non-productive time is one low-hanging fruit that can generally be addressed with new or better drilling techniques combined with new technology. Improving drilling performance with new and better predictive and responsive technologies such as MPD is another area that can drastically reduce overall well costs. And improving well integrity and safety with additional flow control barriers such as a rotating control head is another opportunity for lowering costs. So if you look at the Golden Triangle on your left, which is synonymous with Gulf of Mexico, Brazil, and West Africa, they all have numerous issues, numerous opportunities, and numerous risks that are associated with drilling in these environments. These include water depth. If you look at the water depth, it's changed considerably over the last 10 years, and even before that, in the last 15 years. The geological complexity, reservoir characteristics also have changed with rigs being built deeper to drill in these type of environments. So whether it's ultra HPHT, pre-salt, rubble zones, pore pressure, fracture gradient uncertainties, and complexities all add to the non-productive time and risk to an extensive amount of drilling operators. So to highlight this further, if you look at the risk, you look at non-productive time, and you look at failed well objectives, they speak for themselves. 30% of non-productive time is associated with a typical deepwater well. 46% are down to failed well objectives, which could include reaching total depth, landing intermediate casing strings at depth, and or losing well bores due to kick loss type scenarios. And in a post-Macondo era, risk can be easily quantified now. So just stepping back a little bit and providing some further context and insight into the general market conditions, let's take a look at the current active market of offshore drillers. This is always a good activity benchmark when looking into the future. Contracted rigs stand at 81% and 84% for jackup and floating rigs respectively. Continued declines are also expected from the highs of 2014 as we move out into the end of the year and into 2016. However, when one looks at the new build market, the story becomes even more concerning. You can see the portion of available rigs is significant, especially when considering the new build jackup market. Why do I highlight the active and new build markets? I do this because not only is it a good general indicator of what's to come, but also to highlight the requirement for high specification assets that the customers will naturally demand when growth returns. I will touch on this later in the discussion. So in summary, we believe deepwater is here to stay. However, day rates are declining and rig availability will continue to increase. Our customers will demand high specification drilling units in order for them to deliver wells safely and on budget. And key technologies that can assist in both, such as MPD, will continue the expansion into the mainstream and the new drilling convention. Now let's spend a little time on how deepwater challenges can be addressed. Again, bearing in mind the high non-productive time and failed well objectives that are prevalent in this environment. First, let's spend time on what MPD is for some that are not familiar with the process. IACK widely accepts the definition internationally for MPD as being defined as an adaptive drilling process used to precisely control the annual pressure profile throughout the wellbore. This is achieved by surface back pressure adjustments, with the planned intention of avoiding continuous influx of formation fluids to the surface, unlike UBD. And if any other influx is incidental to the operation would be encountered, it would be safely controlled utilizing the specialized equipment. So a few brief objectives of MPD. The first is to establish the downhole pressure limits to mitigate the risks and costs associated with drilling wells that have narrow and unknown downhole pressure limits. And two, proactively manage the annular hydraulic pressure profile, allowing faster corrective actions to deal with observed pressure variations, such as kicks or losses. So if you compare conventional drilling to managed pressure drilling, what are the differences? So comparing the hydraulic calculation of conventional to MPD applications, in simple terms, conventional applications controlling the bottom hole is based on hydrostatic pressure of the static mud weight plus the frictional pressure. And manipulation of the bottom hole pressure is attained by adjusting either the mud weight or the pump speed. Fairly straightforward. On the other side of the equation, managed pressure drilling applies a closed loop system with the ability to hold surface back pressure. The bottom hole pressure is manipulated by adjusting the chokes with no need to vary hydrostatic mud weight or pump rate. So how is this accomplished? What you're looking at here is a full deepwater spread offshore, with surface back pressure being that new tool for drillers to be utilized across numerous applications and drilling environments globally. So at the far right, you've got your power unit that controls the chokes and other valving within the system. You have your microflux control system, which has the control and detection skids incorporated within them. Occasionally you'll have buffer manifolds. And down below the water line, or at least the rotary table, you'll see the MPD riser joint, which is made up of a flow spool, which allows you to take fluids to surface in a pressurizable manner, an annular isolation device so you can remove your RCD if and when required, and then ultimately closing the loop, enabling the drilling and rotation of pipe. A rotating control head is utilized. So more on the RCD and one key enabling technology for use of surface back pressure. This device serves as both a flow control barrier between the well and the rig floor, but also enables fluid to be diverted back to pressure devices, back pressure devices for better control and visibility of the downhole environment. So as you can see here, a bearing slips in and out of the main housing, and the elements on the bottom provide the seal around the drill pipe and allows you to rotate as you drill ahead. So here's a picture of the automated microflux control system. Again, one key technology that enables better detection and control of the fluid environment within the wellbore. Whether it's early kick detection and response, or in trying to improve your drilling window by understanding pore pressure and fracture gradient values better, is another key area of the technology in reducing non-productive time. So enabling this connection between downhole and topside equipment control, such as RCD and Microflux, our OneSync software platform integrates planning, simulation, and control during MPD operations. So what does this look like? This platform allows for seamless data integration from pre-drill models and planning through MPD operations and post-drill wrap-up. The value to the customer includes reduction of non-productive time due to drilling challenges, better quality wellbores, and improved drilling hazard mitigation while reducing costs and improving safety. Some examples of this would be early kick detection and constant bottom hole pressure for improved wellbore stability and hole cleaning. So before moving more into the new technology discussion, let's summarize why MPD is important. As discussed, easy reserves are gone. Cost pressures are here to stay, and at least for now, with regulatory requirements increasing, which also needs to be addressed. MPD overcomes conventional drilling shortcomings in environments such as deep water, where they're likely to fail. From a technical perspective, and in simple terms, MPD provides the ability for early identification of events, visibility, and ultimate control of the hydraulic drilling environment. So referring back to the first couple slides, and 2003 as the year for introduction of the technology, let's review how MPD's value has changed from early 2003 to where we are today, and how we see wide industry adoption occurring through 2018. So if you look at the undrillable portion, which really happened between 2007 and 2012, the customer really wanted increased safety and efficiencies. They wanted the benefits of it and didn't really look beyond it from a drillability and getting their wells to TD. The market did move slightly then, but it was far from being accepted and would be deemed more of a niche technology as compared to anything else. And it was really, the conversation was contained to, how can I drill this well? So moving through the growth phase to where we are today, or at least in the 14, a term in the industry was coined with customers contracting rigs that they specified as MPD Ready. Although there is no definition to date on the requirements for MPD Ready, the expectations were clear. The customer saw the value of MPD and needed it beyond the undrillable wells. The lack of definition of MPD Ready led to limited systems integration, inconsistent business and commercial models, and ultimately higher costs for our customers. So moving away from this system-based approach as compared to a multi-service approach, eliminating complexity and enabling one platform to control topside through bottom hole will be imperative in meeting the cost objectives of our customers and moving MPD into the mainstream and the new drilling convention profile. Examples of this include providing fail-safe systems which are integrated and scalable to meet well control requirements. Reducing the reliance on human factors through automated response and control. So looking at the system-based approach and looking beyond costs, simplicity and modularization of equipment and greater system integration which are aligned with our customers' objectives, both rig contractor and E&P customers, is imperative. Diversifying in order to meet this expectations and objectives of our customers will be a diversified business model and is across a broad spectrum from capital sales and service. Consider this being a coming together of business models that have been looked at separately. So fully connected products, topside through bottom hole, with the service and the equipment speaking together. So again, in summary, full capable MPD rigs. What does this mean? Reduce implementation timeline. This would be rig up, deployment, and everything associated with what happens on the rig. Reduce complexity with a system approach. Again, topside through bottom hole. Reduce operational risk. Reduce financial risk and human factors, leading to more automation. Better data and interpretation and response from a geological perspective. Reliability and solution-based, from equipment to people that are on the rig. And ultimately scalable, integrated technologies, topside through bottom hole. One size doesn't fit all, but in terms of scale, we can tie in with our OneSync software platform, and then scale based on the need of the well, whether it just be a rotating control head or riser gas handling and microflux. So moving beyond MPD and utilizing the same approach on a system integration level, enabling one drilling control system will be key in achieving the objectives of our customers and ensuring they meet their cost, risk, and performance objectives as we go forward. Integration of the MPD application with hardware through one unified platform will be key areas of development for us now and into the future. So aligning objectives and providing a system-based or integrated MPD offering will move the technology from critical mass to mainstream in the coming years. MPD will continue to address customer risks and costs through this integration process. The removal of the multi-product service line approach will reduce complexity and ultimately improve reliability and efficiencies throughout the entire drilling process. So to give you some idea of key focus areas in terms of technology, this includes, I touched on it a little bit already, with one drilling control system, having the equipment and the service and the application connected. Again, having that space where we can leverage our experience with MPD and build and grow and tie in more drilling hardware to improve the drillability of the well. Enhancing well control. We're doing this now. We do it often based on some of the wells that we're on. So enhancing well control in the sense of early kick detection, improving that capability, which we have today, but getting better with it in terms of accuracy, understanding kick dynamics and well control dynamics, automating the processes where they make sense and where our customers are comfortable with, which again we do have experience in terms of circulating kicks off bottom automatically. And then enhancing our geoscience expertise in terms of sub, pre-salt, and some of the other complexities that are associated with some of these deeper rock types in deepwater drilling. And then ultimately moving towards gaining full understanding of drilling efficiencies and how it impacts our customers and how we can impact overall well costs. So before moving on to the Q&A session, I'll spend some time on our OneSync software platform, and again on how technology connects the hardware and software through a seamless user interface. So the OneSync platform has really been built on the learnings of our business being in the MPD space for over 15 years, and obviously on a worldwide basis as well. So really starting from a trend modeling perspective through analysis and control and building towards optimized drilling processes, this is really our target and key objective. Building on our analysis, interpretation, and control expertise is really a natural segue into further optimization of MPD and other drilling functions, including automated process where practical, to drive further efficiencies into the well construction process. So in short, OneSync enables the operator to trend, analyze, predict, and ultimately control the wellbore from one single user interface. A significant step forward as compared to the multi-product service line approach. So an example of the OneSync platform is our well planning software, which is closely tied to the operational components of our MPD system. This platform was built with MPD in mind, and whether you are using pre-drill or real-time data, it can easily be moved from one application to the other, eliminating duplication and the need for multiple data sets. An additional benefit of this platform is the model engines are combined, ultimately improving pre-engineering simulations and planning. So the features of OneSync are many, but one key and exciting feature is the ability to model at both the rig or the office. This modeling can occur as you are circulating out of a kick, for example, in real time for better understanding of phase dynamics or simple visualization of where the kick is in relation to surface. The user can also predict events ahead of the bit and what-if scenarios as the well is drilled. Some of these real-time engineering tools include hydraulic analysis, formation and pore pressure prediction, and wellbore stability, as well as fracture pressure calculations, as well as torque and drag and buckling and analysis, to name a few. Again, reiterating our belief for the new drilling convention and the technology moving into mainstream adoption in order for us to meet this target, training and competency of all personnel will be crucial. To address, Weatherford has entered a partnership with Maersk Training to deliver comprehensive competency and well control training for MPD personnel worldwide. The program will fully integrate the OneSync platform into the MPD simulator for scenario-based training, such as well control. Maersk Training has officially opened their offices in Houston, amongst others globally, and will provide us with the ability to use scenario-based training for rig crews and MPD personnel. This, we believe, is a significant step forward for wider industry adoption of the technology. Lastly, on the OneSync software platform, we can integrate the functional requirements of all the equipment installed on the rig for the purposes of MPD from one common control system as dictated by the desired application, whether it be constant bottom hole pressure, pressurized mud cap drilling, returns flow control, or drilling with continuous flow. The wider capability of this enhanced software platform will bring together the surface operating capabilities with the subsurface requirements as deemed necessary by the geoscience and drilling engineering departments. In general, the software has the capability to perform pore pressure and fracture pressure prediction, provide an analytical tool to determine torque and drag, and a hydraulics module which will allow the drilling engineer to simulate any hydraulic function, including simulating and monitoring kick dynamics. These are just a few examples of the capabilities of this new and improved MPD system. So now we'll address questions from the audience. If you have questions and haven't done so already, please submit them via the red Q&A icon. If I can't get to some, I'll personally follow them up and get back to you as soon as I can. And we'll start with the first question. What are the most important steps? What are the most important steps that need to be taken to move the industry closer to realizing MPD ready rigs? I think the most important step really is, I believe it's happened. I think, with the benefits that the operator is seeing utilizing MPD. Obviously, the rig contractors are experiencing the same. There really has been sort of a coming around in terms of the technology acceptance with the rig contractors. They're certainly willing, and they see the potential of MPD on the rigs as just another top drive. And so I think we've passed some of the critical steps already with the conversations that we have. Moving it forward now, it really comes down to a conducive market that will allow us to spend money and obviously see return on that, which any company desires. So I think it's going to take time to further expand it, but I think we're over the hump in terms of getting past the hard part with our customers, both E&P and rig contractors, really seeing the benefit of the technology. So second question here, how many of the new build rigs are either planning on using MPD or preparing to be MPD Ready? Rough numbers. Well, if you would have asked us a year ago, there was plenty, probably over 50 rigs, say mid-year 14. Seche Brazil had a significant portion of the new builds, and depending on the contractual requirements out of Korea and Singapore, there was commitments that have been made and unfortunately later canceled. So giving you rough numbers, we've installed permanently MPD equipment on 2 rigs. We have installations on probably worldwide another 10 to 15, I guess, on a traditional rental service package that haven't necessarily been sold. So all in, I would say we're looking at about 20 to 25 rigs. Just looking for another question here. Since IADC defines MPD as a method technology to avoid influxes, what is your position regarding drilling in underbalance and total loss zones? PMCD, for example, influx will happen immediately when drilling in underbalance. Well, if you take Southeast Asia, for instance, pressurized mud cap is used extensively, and predominantly the reason is because they have buggy formations that can't sustain a fluid column past a certain height. So going to a pressurized mud cap system and having a mud cap on top of your loss zone allows you to manage any gas migration that you may have come to surface. So the alternative would be having gas to surface but with no head on top of it to keep it in place. So we do that extensively offshore. Again, in Asia, we've done some in Brazil, but overall, that region speaks to drilling pressurized mud cap with complete losses. And then if you look at the underbalance, so we're getting more and more applications with statically underbalanced mud. And like I mentioned in the start of the presentation, it's a little bit different than conventional well control because you manipulate your effective mud weight or equivalent mud weight with back pressure as compared to barite or whatever it may be, or gels. And so we're starting to see a lot of uptake in terms of drilling statically underbalanced, and then when you turn your pumps off, you've got your back pressure to compensate for the frictional losses in your wellbore. And we've been very successful in doing that, and to be honest, we haven't taken a number of kicks despite intuitively you presume we would. So at the end of the day, when you look at something like this, is we're able to drill in extreme environments, difficult environments like PMCD, with total losses that stop gas migration, and then statically drill on some of these harder wells that, again, won't take a full fluid column or have a very, very narrow drilling window, and ensure that we can drill these wells overbalance with the back pressure, but statically under balance with a fluid. So hopefully that answers your questions. If not, just feel free to add on. But no, we can do that and minimize kicks in general. How many below tension ring systems does Weatherford have today? That'll be about the same, 20 rigs, maybe 22. Yeah, 20 to 25 rigs. It's a little bit dynamic, and I hesitate to answer. Brazil is very dynamic, so we're going through this now. With the majority of it, I think, settled out. But anyways, if you look at our peak, it was above 25. Today, we're probably 20 to 25 systems out there. How will the low price of oil, I presume, impact expected mainstream adoption of 2018? Yeah, it's a difficult one. It's I think in this environment, there's not going to be a lot of investment. If you believe what we presented earlier on high spec differentiated assets, I think it'll move. I think MPD will become part of that. Like I said, the new drilling convention, but the low commodity pricing doesn't help things to move along quickly. So I think inherently it will be impacted. I just don't know how much. You're starting to see a little bit of a shakeout now in the market, where rigs are slowly. I know there's a lot of them coming off next year, but it wasn't quite as bad as what you saw in the first half of this year. So I think we're just going to have to watch this space if that makes any sense, and just see. But if it stays like this for the next 18 months, it's definitely going to impact it. If we can get through half of next year with some I guess ability to see beyond a quarter or two, then I think it'll start to pick back up again. Do you foresee a similar technology path on land as in offshore deepwater applications? Yeah, absolutely. I think much different infrastructure and cost structures in place, especially with the unconventionals. But definitely, when you look at managed pressure drilling, it has an application on land. I think getting that price point down to a manageable figure, where you can clearly see the benefits of the technology versus the well cost. That's really where the magic comes in terms of whether or not you're going to be successful on land or not. I think we've got some novel technology there, which has really been built on the back end of a deepwater system, but specific for land. So yeah, changing our focus, I think, is happening. And again, it makes a lot of sense for us. We've got a ton of infrastructure in the U.S. and in Canada, and to a certain extent in Latin America. We got 50% plus market share of rotating control heads on land, and leveraging that piece and pulling through additional pressure control equipment like microflux only makes sense. But again, it comes down to the right price point, and obviously showing the value of the technology to the customer. What sort of time cost savings are operators seeing by utilizing deepwater MPD? That's a good question. I guess they're few and far between, but for the most part, I'll use an example that I read today, where a deepwater well in the Western Hemisphere, it was more or less deemed undrillable. They could get into the top of the reservoir, drill a certain amount of feet, and then they would end up losing everything. So the next go around, they used MPD equipment, and they drilled a 400-foot open hole section with limited problems, didn't lose any fluid. And so the first benefit is they opened up the pay zone significantly more than what they could have done drilling conventionally. the well is producing a significant amount of oil, which is I guess the name of the game. But more importantly as well, you look at the day saved. So they were fighting losses for over 15 days. We drilled through it in somewhere between 4 and 5 days. And so again, there's 10 days of savings there. There's no mud loss costs. And then more importantly, putting the value on a significant well that's producing today is good. And that's where we want to be. We need to be able to save time, reduce risk, and ultimately to deliver the well to TD. And if we can do that, I think MPD will have a long and sustained life. All right, another question here. When will we have more expectations for more grow up with MPD? What will be the better year? So when do we expect growth to pick up, right? What will be a better year? Well, we saw declines in 15, so 16 should see growth. I think with what we have working, and not just Weatherford, but as a community, it's significant. It's actually more than 15, and some very, very good projects that, from a technical perspective, need MPD. So I think you're going to find areas like Brazil be slow for 16, for obvious reasons. West Africa will pick up later in 16. Asia will remain strong for us throughout 16 and 17, and same with the North Sea. We've got some other opportunities in and around some unconventional bodies of water, but nonetheless, we see 16, the later half, getting much better. Okay, another question. Do you have a breakdown of the well types that MPD is utilized on? Example, exploration, development, workover. So, a little bit of both, actually. If you have to split it down, I would say we're probably 50% exploration, 40% development, and 10% workover, something like that. Or maybe 40-40-20. But yeah, we do a significant amount of work on both exploration and development, and we had a long run in South America with re-entries and workovers and reclaiming the wellbores there, and highly successful. So yeah, I'd say maybe 40-40-20, something like that. So is there another question here? Is there a significant difference in terms of cost? I presume significant difference between the cost of the rig and cost of MPD, right? And it's there is a difference. Two different services. But ultimately, when you combine the services, you need to be providing some sort of value to the customer and to the operator. And that value's got to be in reduced drill time, reduced risk, reduced cost, whatever it may be. So when you look at the well cost as compared to the cost of the individual services, gives you a much better representation of the value that the technology can bring. I'm just looking at some of the last questions here. Is the well control module based on single bubble model, or is it a more advanced model using handling dispersion, OBM solution effects, etc.? Well, we have both. We have the single model, and we're looking at dispersion and miscibility as well within a transient model. If if you want more information on on how that works, please feel free to email me, and I'll get our engineers that developed it to provide some information. Just seeing if there's any other questions. So, I think this will be the last one. Future challenges for MPD. Wow. It's a good one. I think when you look at MPD and how it's evolved, I think like I said in the discussion, is there needs to be a base package, needs to be modular, and it needs to be specific to the application. So having a system in place that's connected, topside through bottom hole, that you can scale depending on what the well requires, I think is a challenge, because you can't be everything to everybody. And if you look at the infrastructure challenges that we've had over the past few years installing these packages in deep water, I think they need to get a little bit smaller, more nimbler, and faster, right? And I think with the continual technical evolution, especially in well control and MPD, I think the systems need to get better. They need to get more reliable. They need to be more consistent and ultimately more automated, as long as the industry wants to go that way. So more technical challenges than say business-related challenges in terms of MPD acceptance in the industry. And then ultimately, when will the market turn, and when are drilling contractors or E&P providers willing to step out and put on differentiating technology that they think they can drill wells better, faster, cheaper, right? Any other questions? That's it. Okay, that's not bad. That's all the time we have today. And again, thank you for joining us for this webcast. And we look forward to seeing you again in next year's series. Thanks again from everyone here at Weatherford. Appreciate your time, and have a good day.